Alright, so in this problem, I have 5 to the power of x plus 25 to the power of x is equal to 20. So to solve this, I'm going to first rewrite 25 here as 5 squared. So now I have 5 to the power of x plus 5 squared to the power of x is equal to 20. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So 5 to the power of 2 to the power of x, I can switch the places of 2 and x. So now I have 5 to the power of x plus 5 to the power of x squared is equal to 20. Now I'm going to let 5 to the power of x equal to the variable y. So now if I substitute in y for 5 to the power of x, I get y plus y squared is equal to 20. And I can rewrite this as y squared plus y is equal to 20. So now I'm going to subtract 20 on both sides. These two cancel out, and I have y squared plus y minus 20 is equal to 0. So now all we have to do is simply factor this out. Y is the same thing as 5y minus 4y. So now I'm going to factor by grouping. So first, from here, y squared plus 5y, I'm going to factor out y. So I get y times y plus 5. Minus from 4y minus 20, I'm going to factor out negative 4. So I get negative 4 times y plus 5 is equal to 0. So now if I factor out y plus 5, I get y plus 5 times y minus 4 is equal to 0. So now this is going to give me two equations. I have y plus 5 is equal to 0, and I have y minus 4 is equal to 0. So for y plus 5 equals 0, y is equal to negative 5. And for y minus 4 equals equal, y equals 4. Now, remember how we let 5 to the power of x equal to y. So now this is going to give me two equations. I have 5 to the power of x is equal to negative 5, and I have 5 to the power of x is equal to 4. So first off, 5 to the power of x equals negative 5. Well, I can't take the power of a positive number and make it a negative number. So this is wrong. This equation is wrong. So now this leaves me with 5 to the power of x equals 4. So to solve this, I'm going to first take the log on both sides. So I have log 5 to the power of x is equal to log 4. This is the same thing as x times log 5 is equal to log 4. And if I divide both sides by log 5, I get x is equal to log 4 over log 5. Alright, so in this problem, I have 3x to the power of 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. So to start, I'm going to first rewrite all of these terms. So I'm going to rewrite 9 to the power of x as 3 squared to the power of x. And 81, I'm going to rewrite as 3 to the power of 4. And the reason I did this was because now all my bases for my terms here are 3. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, I have 3 to the power of x to the power of 3 divided by 3 to the power of 2 to the power of x. Now 2 to the power of x, that's the same thing as, well, if I have something in the form a to the power of m to the power of n, that's the same thing as a to the power of m times n. So 3 to the power of 2 to the power of x, that's going to equal 3 to the power of 2 times x, which is 2x. This is equal to 3 to the power of 4. Now, a to the power of m over a to the power of n, that's equal to a to the power of m minus n. So this is equal to 3 to the power of x to the power of 3 minus 2x, which is equal to 3 to the power of 4. Now, if I have something from a to the power of m is equal to a to the power of n, this means that m is equal to n. So x to the power of 3 minus 2x is equal to 4. So now I have a simple equation here. I'm going to subtract 4 on both sides, and I get x to the power of 3 minus 2x minus 4 is equal to 0. So to actually solve this, I'm going to first start by getting one value of x, And then using that value, I'm going to get the remaining values. So to get that one value, I'm going to just have to test values out. So let's first start by testing out x equals 1. So if x equals 1, we have 1 to the power of 3 minus 2 times 1 minus 4 is equal to 0. 1 to the power of 3 is 1. So I have 1 minus 2 minus 4 is equal to 0, which is negative 1 minus 4, which is equal to negative 5. So this is wrong. So the next value I'm going to test out is 2. So if x equals 2, I get 2 to the power of 3 minus 2 times 2 minus 4, which is 8 minus 4 minus 4, which is 0. So 2 is going to be a value of x. Now using this value, we know that x minus 2, this is a factor of x to the power of 3 minus 2x minus 4. Because when we plug in 2 for x minus 2, that's 0, so x minus 2 is a factor. So now, if I divide x to the power of 3 minus 2x minus 4 with x minus 2, I'm actually not going to waste you guys' time by actually dividing these two, but if you do divide these two, you should get x squared plus 2x plus 2. So this is the same thing as x minus 2 times x squared plus 2x plus 2 is equal to this, or also equal to 0. So now this gives me two equations. I have x minus 2 is equal to 0 and x squared plus 2x plus 2 is equal to 0. For x minus 2 equals 0, x is obviously equal to 2. And for x squared plus 2x plus 2 equals 0, you have to use the quadratic formula for this. But if you do, you should get x is equal to negative 2 plus or minus the square root of 4i over 2. So this is two other answers. All right, so I'm going to be proving that 0 divided by 0 is equal to 2. So to do this, I'm going to first start with 0 divided by 0. So 0 divided by 0, this is the same thing as 1 minus 1 over 1 minus 1, because 1 minus 1 is 0, so 0 over 0, 1 minus 1 over 1 minus 1. Now 1 minus 1 over 1 minus 1, this is the same thing as 10 minus 10 over 10 minus 10. Again, 10 minus 10 is 0, so I have 0 over 0 again. Now 10 minus 10 over 10 minus 10, this is the same thing as 100 minus 100 over 100 minus 100. Again, 100 minus 100 is 0, so it's the same thing. Now I'm actually going to simplify 100 minus 100 over 100 minus 100. So 100 is the same thing as 10 squared, right? So this is the same thing as 10 squared minus 10 squared for our numerator, because 10 squared is 100, so 100 minus 100 is the same thing as 10 squared minus 10 squared. And for my denominator, 10 squared, this is the same thing as 10 minus 10. So I'm going to write 10 times 10 minus 10 times 10. And this is again equal to 0. This is still 0 over 0. And now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So 10 squared minus 10 squared, this is equal to 10 plus 10 times 10 minus 10. So again, this is completely legal. I'm just using a property of exponents. And for my denominator, I'm actually going to factor out 10. So now I get 10 times 10 minus 10. So now I can actually go ahead and cancel these two 10 minus 10s out. So now I'll be left with 10 plus 10 over 10. 10 plus 10 is 20, so I have 20 over 10, which is equal to 2. So I just proved that 0 over 0 is equal to 2. Now obviously 0 over 0 is not equal to 2, and the mistake in this proof is right here when I canceled out 10 minus 10 over 10 minus 10. So what is 10 minus 10? 10 minus 10 is 0. So I'm technically canceling out 0 and 0. And remember, 0 over 0 is not equal to 1. So I can't actually cancel these two out because that's essentially implying that 0 over 0 is 1, which it's not. So that's a mistake in this proof. And 0 divided by 0 is not 2.